Good morning, everyone. This is Dennis Bauer. I'm an extension educator in Brown, Kippaw, and Rock County. Work primarily in the beef systems area, work with ranchers on cow-calf nutrition, mineral type programs. Today I'm going to share with you a program on balancing the ranch for protein and energy. And is it possible to meet the nutritional needs of cows and calves with the forages that we put up? Can we put them up high enough quality to do that? Well, we will discuss today, we'll talk about protein and energy requirements for cows, what affects the quality of the forages that we put up, and what is the cost of high quality forages. And then at the end we will show you some examples of forage tests that we've had analyzed here this past year from area producers to give you an idea of what high quality forages might look like. So let's get started. I think what we need to do to start with is to look at the requirements for cows. These requirements come out of the NRC. And if you take a look at a 1,200-pound cow, 20 pounds of milk during lactation, she needs to be about 10.5% protein and has a TDN level of about 60%. That same cow, if she's producing 30 pounds of milk, will require about 11% protein and 63% TDN. And a dry cow there at the bottom of this slide, 60 days prior to calving, 7%. 50 on TDN. And so, we can use some relatively low quality roughages through some of her production cycle, and that's why corn stalks work really well. And then prior to calving, just to show you that the nutrient needs start to go up as she gets closer to calving. If you look at the heifers, on this slide, 1,100-pound bred heifer, 150 days pregnant, about 7% protein, 52% TDN. As she gets closer to delivery, the requirements go up to about 10% and 60% TDN. And then after calving, that 1,100-pound heifer will be up to 11% protein and TDN level of about 62% in her diet. And the question comes, can we produce forages that are high enough quality to meet the heifer and a cow's need even after calving? That's really the crux of the discussion today. Can we do that? So let's get into looking at some of the data points or data sets that we have on putting up quality grasses and forages. And it really boils down to the stage of maturity when those plants are harvested. That really determines, for the most part, what kind of quality that you will have when it comes to protein and energy. This slide demonstrates brome grass, smooth brome grass, for example, versus 8 other cool season grasses. And when those plants are in the vegetative stage, you can see that we can be approaching 20% protein on brome grass. Then we get to heads half emerged, we drop down to 16% protein. The flower parts fully expanded down to 14. Then when we get into bloom and milk stage, we can drop down to 8% protein rather quickly. And this all happens in a period of about 2 to 3 weeks. It can, depending on the weather. And so the quality really declines quite rapidly after we get to the seed head production stage on those plants. Here's another data set. I collected this set of data over a 2-year period in early 90s, looking at smooth brome grass, Hawaii intermediate wheat, and high grass crested wheatgrass on a research trial we did here in north central Nebraska. And again, just to give you an idea, when we started harvesting those plants in early June, take smooth brome for example, we were already at about 10% protein and had a TDN level of 61. And as we moved the cutting date throughout the season into the middle of July there, we were down to 6% protein protein on the 25th of June. So about a 3-week window there, we dropped about 40% of the protein out of that particular forage, and we had a 12-point decline on PDN in a 3-week period. This is a shot of some heifers that we had on those grass trials that we did back in the early 90s here in north central Nebraska. We actually grazed those heifers on those different grasses all spring, and really got some nice acceptable gains on those heifers. These heifers would gain over 2 pounds a day on any of those grasses when we turned out in May when they were in the vegetative stage. This is some work out of Goodmanson, Dr. Jerry Valesky and others. Dr. Jim Nichols actually did some of this work 2 years ago. We look at harvest date on the perennial grasses. On the left, you can see where they started harvesting on June 1st, and then 2-week intervals. You can look at the yield and then the crude protein content of that forage that was harvested. Then they came back in the end of September and harvested those same plants again, those plots. You look at the crude protein content of the second harvest, and then on the far right, you have the total yield. Notice that when you get here, when you cut earlier, on June 1st, the total yield was a little bit less than when they harvested here the first part of July. And so July 1, and then they cut back in September, they were basically maxed out on yield. And look at the quality of the regrowth, about 12.5% protein, 8% protein on the first cutting. So in most cases, if we would look at, if we wanted to cut on the calendar here on cool season grasses, then we need to be putting them up in late June at least for decent quality forages, but should really be based on seed head development when those plants are in the late boot stage or the heads are just starting to emerge, really to get the most quantity and quality out of the forages that we put up for hay. Talk a little bit about fertilizer treatments. In this respect, we can sure increase quantity with fertilizer. I'm not so sure that we can increase the quality of the forages that we put up. In this example, again, this is data from Dr. Jim Nichols at North Platte. Here's the check where it produced, those meadows are producing just over 2 tons per acre. And here's the 40 pounds of nitrogen, 40 pounds of P2O5 per acre, with the sulfur at 65/40. About a ton yield increase, bare dried forage with an application of 40 pounds of nitrogen and 40 pounds of P2O5. We definitely can get a yield increase most years, somewhere between 3/4 and a ton more forage per acre. But does it really add to the quality of the forages? And this is the rest of that story from that data set. Notice here the check. They didn't put any fertilizer on, crude protein. They tested that over a 3-year period, averaged about 9% protein. And the minute you started putting nitrogen and or nitrogen and phosphorus, or nitrogen, phosphorus, and sulfur together, the quality sure did not increase. Now, statistically, there was no difference in these numbers, but the bottom line is we didn't increase the quality from a protein standpoint, but with the addition of nitrogen and or phosphorus fertilizer. So again, we can get a quantity increase, more tons per acre, but we don't necessarily increase the quality of the forages that we produce with the addition of fertilizer. Switching gears here a little bit, we'll go into some of the spring cereal crops now for forage. Dr. Jerry Valesky did this work at North Platte. Looked at triticales, a couple varieties of oats, spring wheat, and barley. These trials were planted in April. This was 2012 data. Notice here at the bottom, harvested these at late milk stage, the soft dough. A lot of people will not want to harvest, or they think they need to let it go longer than that. So look at the quantity, acceptable yields, 2.5 tons across there between the oats and the barley, and a little bit of difference there. You look at the bottom line is, by cutting in the late milk stage, still had respectable yields at over 2 tons to the acre. But I get really excited when you look at the quality of material harvested, from 11.6 low on protein up to 14.7. Remember back when we first started this morning, 10, 11% protein will meet the requirements of the lactating cow and or heifer. Most of these forages here harvested at that late milk stage would sure meet the requirement for a lactating cow. And if you look at the TDN levels, the TDN levels needed to be about 60% TDN for those lactating cows. We sure are approaching that, with some in the mid-60s from an energy standpoint. So these spring cereals can be of very, very high quality and meet the cow's requirements after they start lactating. Here's another data set from Dr. Valesky looking at the summer annuals, calf, crabgrass, foxtail millet. This was a data set from 2007 at North Platte. Looked at 3 harvest dates, and probably from a haying standpoint, we would take the first and second harvest, and third cutting would be regrowth or after-growth grazing. But again, acceptable yields, 4 ton here on the Tiffany calf, over 4 ton here on the farrow. Red River crabgrass was at 4.7 ton with 2 cuttings, so on. Really acceptable yields on those grasses. And again, where I really get excited is looking at the crude protein content. The teff, 16 to 18% protein, the crabgrass is at 16 to 17. The foxtail millet even at almost 13% protein. And then the TDN levels again in high 50s to low mid 60s. Again, just to demonstrate that we can meet the protein and energy requirements of even cows during lactation if we put up the forages at the right growth stage or maturity stage of those plants. Just to show you some other data, this data comes from the University of Georgia. They have a lab there that basically tests thousands of samples on a yearly basis. And here on the left, just the different grass. They have orchard grass, pearl millet, forage sorghum, and so on. Here's their average protein content from their lab. Here on the right is the high, and of course the low. And unfortunately, I see a lot of samples that come in on the low end from the test on crude protein. But boy, if we could just put up average quality hay, like here in this column, and we could meet protein requirements of those cows. And if we really pushed it, we could be up here in this 13, 14, 15% protein. Definitely is doable, not only in Nebraska, but across the country. Here's the TDN portion of that data set. Again, on average, the mid-50s. We're pretty close to meeting requirements, but not quite. So if we put those plants up, forages up just at a little earlier stage of their maturity, we could sure be in that 60 percentile on TDN, which meets cow's requirements. And again, unfortunately, a lot of times we'll see our forage test in high 40s to low 50s on a lot of the forages. Again, we're just putting them up at too late of maturity stage to really get into the high quality category. Here's another data set from North Dakota State University looking at the annual and perennial ryegrasses. They cut at the boot stage, 10% protein. They cut at early boot. Look at that. They were at 15 and 16% crude protein. Now that happens in a period of about 2 weeks. So they dropped, almost 6 points of protein off just from early boot to boot. And then these cuttings here, the vegetative ones, are actually after late summer and fall. And look at the quality from a protein standpoint on that vegetative stuff. Again, just a function of age or maturity on those plants when they're harvested. Again, just to show you a little difference on TDN, you've actually seen this slide before today. But look at the TDN, and it has to do with the acid detergent fiber, what is indigestible to the animal. And the lower the ADF, the higher the TDN values. And so there are differences between plants, different forages or cultivars, varieties. Here, teff, 33 and 35% ADF translates into mid 60% TDN values. You look at the white wonder foxtail millet, at the same growth stage, you had 43% ADF, and that lowers the TDN value down to 54.6. And that sure can happen. So there is a difference between the plants and the different varieties and cultivars that we put up in different species, how much ADF they may take. I thought we'd finish up today and talk a little bit about some cowboy math type things. If you look here, I've got an example of how much hay would be required. This would be to feed a cow, 1,200-pound cow, 30 pounds as fed, about 2.2% of her body weight on a dry matter basis. Up here in north central Nebraska, we feed hay after calving. If we start calving March 1st till probably the 15th of May, about a 75-day feeding period. How much hay would that take? Well, here's the number of cows in any particular herd, and let's just say we've got 400 cows in the herd. They're going to need about 452 ton of hay. Do that after calving. And if our forages would produce 1.5 tons per acre, we would have to put up about 300 ton of hay. And if we had 2 tons per acre, would be our yield, we'd be at 226 tons, or 226 acres to do that. Now, if we were cutting annual forages or double cropping, we were producing 4 tons to the acre, we cut that down to about 130 acres. Look at potential savings. Normally, guys up here, if we're feeding low quality hay to those cows after calving, it's not uncommon for them to feed 2 pounds of protein supplement per head per day. And if that supplement is costing right at $400 a ton, that's 40 cents a day on those cows per head. If you look at this same set, then if we feed that 2 pounds of protein supplement for 75 days, and it's $400 a ton, 400 cow herd, we've got about $12,000 in protein supplement along with the hay that we're feeding. In this example, it just shows you what the difference might be between low quality hay and high quality hay, what the cost would be. And again, a lot of ranchers do not test hay when they're buying it, and if the going rate is $80 a ton, it might be high quality hay, it might be low quality hay. So in the first one here, I've got $80 a ton hay, 9.5% protein, TDN level of 59. And that is sure doable. I think you can see from the data that we presented here today. And then we've got a lower quality hay, same price at $80 a ton, but it only tests 6.5% protein and has a TDN level of 52. I see a lot of meadow hays that are right in this range. Then I got a protein supplement, which basically would be a distiller's grain based supplement at $300 a ton, 25% protein and 100% TDN. What would the cost be? This would be for a 1,300-pound cow, about 35 days after calving to meet her nutrient requirements at that time in her reproductive cycle. This is just feed cost. We could feed 32 pounds of the high-quality hay, $1.28. We could feed 27 pounds of the low-quality hay and 5 pounds of that supplement, would be $1.83 a day. Both rations have equal amounts of crude protein and TDN, and this cow will still lose a little bit of body condition over a 75-day period. It's just awful hard to feed a cow, eat all of her nutrient needs after calving. So scheduled it in here that she would lose about a half a body condition score over that 75-day period. But again, both equal on protein and energy. The difference would be $1.83 versus $1.28 or 55 cents a head a day. And again, now if we have 400 cow herd, that is going to be about $16,000 to that producer in extra energy and protein supplements. Where if we had that higher quality hay, we could basically save this money and use it for other things. Actually, that 75-day period would be about just over $40 a head increase in cost if we had to buy something. Just to show you what we have done here locally, I've got 4 samples here. These are actually forage test results from producers that we've worked with here through the Extension Office to put up high quality hay. Irrigated oats, gentlemen up in Chippewa County. We harvested these at the milk stage, 13.3% protein, TDN level of 59.4. Had some barley, tested 10.2% protein, TDN level of 62.8. This is interesting because he's feeding the oats right now on corn stalks, 10 pounds every other day to meet protein requirements. And the barley hay we will be feeding to the cows after they calve because it's got a little higher energy level in it and also still meet those cows' requirements for protein. This is meadow hay sample. Comes from west of Ainsworth here. This gentleman cuts this meadow in usually mid to late June. This year was about the 20th of June. He does that for a reason. He likes to put up high quality hay, and then he has more regrowth. This is where he winters his calves. This meadow hay, which would be Timothy, red top, some smooth brome, some mixture in cool season grasses, 12% protein and a TDN level of almost 60. Just excellent quality hay, perennial forage type hay, grass hay for the cow herd. Then the last one I'll show you is the sorghum hay. This again will be under a pivot. This is brown midrib forage sorghum, harvested before there was any seed heads on it at all, about armpit high, and tested 13.7 on protein and a TDN level of 62.3. Definitely high enough quality to meet a cow's needs after calving, even those cows that may be producing 25 to 30 pounds of milk a day. Just an excellent source of protein and energy for those cows. And all samples are reported on 100% dry matter basis for crude protein. Should also mention, if we're going to produce any of these summer annuals or oats or barley, we definitely ought to test for nitrate before we start feeding them, and that would be another discussion for another talk. In summary, I think protein and energy needs can be met for, in most cases, out of the forages we produce if we put them up at the right growth stage. Again, the growth stage is critical to high quality forage. As those plants mature, the quality really goes down, and that can happen in as little as a couple weeks. Fertilizer has little effect on forage quality, but definitely can increase the quantity of the forage we produce. The data that would suggest that for 40 pounds of nitrogen and 40 pounds of P2O5 per acre, at least on our sub-irrigated meadows and our cool season grasses, we should be able to produce 3/4 to a ton more forage per acre. Really don't think there's much of a yield reduction when we look at cutting a little earlier to put up high quality forages. Normally the season-long production on these perennial grasses, we cut earlier, put up higher quality hay. We're going to end up with more regrowth rather than cutting it later. We end up with less regrowth, and then still at the same time have poor quality forage feed. Management is critical. It's easier to talk about putting up hay earlier than when it looks like it's the oats are in the late flowering stage to early milk, and it looks like it's going to rain for the next week. That may be a difficult decision to when do we hay, those things. But management is critical to do that. And really, the bottom line is I don't think there's any cost or extra cost of putting up high quality hay. In fact, I think it's just the opposite. we can actually save lots and lots of dollars and add to the bottom line by putting up high quality forage. And with that, I'd like to thank you, and everybody have a good day.